So, a little bit longer break than I thought you were going to, and now I'm not sure where we're going from here, but I know that when we last had class, we were talking about various ways to use inverse trig functions in order to integrate problems that were of particular forms, and I'll review that before I give you a test over that material. I'm going to present some more stuff here first. But the next thing that comes along in the text is something that's called hyperbolic functions. Hyperbolic trig functions. Now, what hyperbolic trig functions are is they're a combination of things that we've just learned about with exponentials as follows. The hyperbolic cosine of a value x. So what we get right there is hyperbolic cosine. The h tells us it's hyperbolic, and often people just refer to that either cosh or cosh of x rather than saying hyperbolic cosine all the time. But it turns out that it is just the following. It is a combination of exponential to a positive x, and exponential to a negative x, and then a 2 on the bottom, divided by 2. Similarly, we have a hyperbolic sine, and the only difference between the two of those is that. Now, we've already talked at some point about the fact that you take the derivative of regular sine, and that gives you cosine, and you take the derivative of cosine, and that gives you negative sine. Those we talked about a long time ago. But when we look at this and we think about what we know about the exponential function, if I was to take the derivative of cosh with respect to x, well, what would I do? I look at this over here and I say, well, I've got a 1/2 there, first of all. And then I'm just taking the derivative of this numerator. The derivative of e to the x is just e to the x. The derivative of e to the minus x is minus e to the minus x. And then when I look at that and I say, well, I can put that 1/2 back into the denominator, and that would be precisely the hyperbolic sine, or sinh. So, whereas those are for normal trig functions, when we talk about the derivative of hyperbolic cosh, we get sinh. And similarly, if we talk about the hyperbolic derivative of hyperbolic sinh, we get cosh. It turns out that, and if we think about like where trig functions typically come from, they come from a circle, right? We talk about trig and we talk about the unit circle a lot with regard to that. These are hyperbolic trig functions. They come from a hyperbola instead, and therefore they're a little bit different. But everything about them, the relationships, etc., are the same. So in addition to these two, we have 4 other hyperbolic functions. We have hyperbolic tangent, and hyperbolic tangent, just like regular tangent is sine over cosine, hyperbolic tangent is sinh over cosh, and hyperbolic tangent we call tang. If we think about hyperbolic secant, which we would call sech, it is 1 over cosh. Hyperbolic cosecant, which we would call cosech, would be 1 over sinh. And cotang will be 1 over tang, or as you could write it as cosh over sinh. The similarities between hyperbolic trig functions and regular trig functions lead to similarities between their derivatives. Of course, we know that this is true. We also know that we can take the derivative of other things here. Let me clear out some of this space here. If I find that. So we also have the derivative of tangent, and we know that to be secant squared. We have the derivative of cotangent, and we know that to be negative cosecant squared. then similarly, when we talk about the hyperbolic trig functions, the derivative of tang is sec squared, but it ends up with a negative sign. Okay? Sort of like the negative sign that we had here that we don't have down here, kind of migrates over there. And the derivative of cotang is just as above, cosec squared. We also have the derivative of secant, which is secant tangent, or tangent secant, whichever way you want to write it. The derivative of cosecant, which is negative cosecant x, cotangent x. And when we talk about hyperbolic trig, the derivative of sec x is negative secant x, tangent x. And I'm sorry, this is not the negative, that's the positive. Negative migrates over here. Derivative of cosec of x is negative, cosec x, cotangent x. So, this hyperbolic trig functions allows us a whole new set of functions. And why do we care? Well, I mean, they're different, they describe things differently, etc. But the real reason we care in the context of what we've been doing is that these trig functions and their inverses. If you remember, one of the last things we did before break is that we said we can take an inverse and take a derivative of the inverse. This is the derivative of the function. But the derivative of the inverse was more complicated, but what it gave us is it fit us to a particular form. And that's what's going to happen here is they're going to fit us particular forms. Sometimes there's a square root in the denominator. We've got a number squared minus a variable squared. We've got a variable squared minus a number squared. All those kinds of things that we talked about before break. And these, in that same way, allow us more options. So instead of just the 3 that we developed before, this gives us 6 more to look at and see what they do.